Welcome back to the AI Research Roundup. I am your host, Alex. Today, we're diving into a really exciting paper called Ming-Omni, a unified multimodal model for perception and generation. The big idea here is a single model that can handle images, text, audio, and video for both understanding and creating new content. It uses what's called a mixture of experts architecture, which is like having a team of specialized A's inside one model, making it very efficient. What's really notable is that the researchers claim this is the first open-source model to match GPT-4o's modality support. And for those of you who want to get your hands dirty, the authors have made good on their open-source promise. They've released all the code for this work on GitHub. You can find the implementation details there, along with Python usage examples for all the different tasks we mentioned, like image generation and audio processing, so you can try it out for yourself. Okay, so this first figure really brings the model's capabilities to life. You can see examples of it doing everything from putting sunglasses on a sheep, to generating a photo of a cake, to understanding audio and video. It even reads text from a receipt, which is a task called optical character recognition. The centerpiece is a radar chart comparing the smaller Ming-Lite-Omni model in blue against its competitors. The further a line is from the center, the better its performance. And you can see the blue line for Ming-Lite-Omni is consistently on the outer edge, showing it's a top performer. For image generation, it sets a new state-of-the-art score on a metric called FID, which stands for Fréchet Inception Distance. This is a key measure of image quality, where lower scores are better. Alright, so after seeing those impressive results, let's look at how it all works. This diagram shows the Ming-Omni architecture. At the bottom, it takes in media like images and audio, using dedicated encoders to turn them into tokens. These are processed by the core Ling model, which uses special routers that act like traffic controllers, sending information to the right expert. For generation, the output can go to an audio decoder to create speech, or to a diffusion model for images. A diffusion model basically starts with random noise and refines it into a detailed image, which is how it achieves that high-quality output. So, speaking of that diffusion model for images, this next figure gives us a great look at its output quality. These are all examples of instruction-based text to image generation. You can see the prompts are very straightforward. Things like a photo of a person, a photo of a toaster, and a photo of a cake. The resulting images, though, are really high quality and photorealistic. This shows the model has a very strong grasp of generating images that accurately and faithfully match the text instructions, a crucial capability for a multimodal system. Alright, and the model's creative abilities go beyond just generating images from scratch. This next figure shows off its impressive skill in what's called style transfer. You can see how it takes a source image, like a historical photograph, a cat, or a hedgehog, and then reimagines it based on a new stylistic instruction. We see these subjects transformed into cartoons, Lego figures, and even simple line art sketches. This ability to apply a specific artistic style shows a more nuanced level of control. It's not just creating an image, but transforming one based on a creative prompt. Building on that idea of modifying images, this next set of examples shows an even deeper level of editing control. While we just saw how it can change the overall style, this figure demonstrates the model's ability to make very specific semantic changes. You can see it replacing a pizza with a cake, swapping an elephant for a giraffe, and even completely removing objects from a scene, like the giraffes in that zoo enclosure. It can also replace a train with a bus, or add a rainbow to a landscape, all while keeping the rest of the image perfectly consistent. So, after seeing all those impressive editing skills, the natural question is, how does one model learn to do so many different things? Well, this figure gives us a look at the recipe, the specific data it was trained on. The training is split into two main phases. The top row of charts shows the pre-training phase, where the model learns general world knowledge. It starts with mostly image and text data, but gradually incorporates more variety like web pages, code, and video. The bottom row shows the instruction tuning phase. This is where the model learns to follow specific commands. And here, the data mix is much more diverse, with dedicated slices for skills like grounding, which is linking text to parts of an image, and understanding graphical user interfaces, or GUIs like on a phone screen. This careful, staged approach to data is key to building such a versatile model. Alright, and that diverse training data really pays off when we look at the results. This table compares the performance of the smaller Ming-Lite-Omni model against several leading models on various image and text benchmarks. And even though it's a lighter version, it's incredibly competitive. For example, it achieves the top score on Math Vista, which tests its ability to solve math problems found in images. It also scores highest on OCR Bench, a benchmark for optical character recognition. Basically, how well it can read text inside a picture. These strong results show that its specialized training gives it a significant edge in these very practical perception skills. These impressive benchmark scores really highlight the power of Ming-Omni. The key takeaway here is the effectiveness of its two-stage training process. First, building a strong perception foundation, and then fine-tuning for instruction following. This work shows a promising path toward creating more capable and unified multimodal AI models that can truly understand and interact with the world in a more human-like way. That's all for this week's AI Research Roundup. Thanks for tuning in, and I'll see you next time.